refining petroleum. So we're going to talk a little bit about crude oil and about how it's refined. We did talk about this a little bit in the fractional distillation notes. So I'm just going to elaborate on what crude oil is a little more. So crude oil can come in many colors. It can be colorless, it can be dark green, it can be black. It has, I guess, varying degrees of viscosity, but usually it's pretty thick. Viscosity is basically how sticky it is to itself. So water is something that can, you can like swish around and it has like a lot of movement because it has a low viscosity. Water does stick to itself, but not as strongly as something like molasses. And if you don't know what molasses is, honey is something else that kind of has like a high viscosity too, where once you start to like pour it out, it really sticks together. Like it takes a long time for a drop to happen. Depending on what kind of like syrup you might use, that's kind of like that too, like a syrup or like a, I'm trying to think something that's like not full of sugar, but I can't at the moment. Anyway, so that's viscosity. Again, crude oil tends to have higher viscosity, but it can have varying kinds. That you will find some with lower viscosity as well. Crude oil, again, it's unrefined, so it's sort of a mixture of a lot of stuff. So that's why it can be different colors. That's why it can have different consistencies, especially depending on where it's mined from, right? Crude oil is made from the decaying of fossils, which takes millions and millions of years to do. And so because of that, who knows what gets mixed in with that in the meantime, again, giving it different colors and different viscosities. It's transported by either a pipeline or an ocean tanker. You can see in the picture that the pipeline there is above ground, and sometimes they are, sometimes they're below. I think that picture specifically was from like Russia or something. I've never personally seen a pipeline like that in person. I've only seen pictures, but that pipeline is huge. Like it's probably about the size of a person. Like if you were standing next to it, it might be about the size of you. So maybe like 5 feet in diameter. It's really, really big. It can also be transported by oil tanker, which is the other picture that you can see there on the right. Huge tanker ships. The problem with transporting it by ocean is we've seen in our lifetime big spills that have happened in the ocean. And when it does that, it kills a lot of marine life and, affects like the food cycles and stuff. And if you ever see like water on fire, it's because there's some sort of oil in there. So again, that would be from like an ocean tanker spilling. So it's a little more dangerous to transport it by ocean tanker, but those are the two ways that we do it. Those again are huge ships. I don't know if you can see in that picture, but what's going in between them is a very, very large like dock. And that actually has cars and like people on it that are so like microscopic in this picture you can't even see. So again, those are huge ships. Most of petroleum is used as fuel for like factories, to make factories run, and fuel for things like big like ships, like transportation, big planes and stuff like that. As far as like our daily use of cars, petroleum I think is like 3% or something like that. So when we say fuel, we're talking about fuel as a whole. That is including cars and stuff, but we're also including like massive transit, and we're also including so like trains, stuff that go all the way across countries. And then we are also talking about factories. Factories need fuel too, and most of them run on petroleum. Most of them do not run on hydropower. They don't run on solar. They don't run on wind. I mean, factories are making changes, but most of them run on petroleum. And they also like are used as a building material. So petroleum is mostly used for either fuel or building materials. When we say building materials, we're really talking about plastics. So every time you buy something that comes in a plastic container, or it's wrapped in plastic or something like that, that was made with petroleum. But the problem is that petroleum is a non-renewable resource. It is created from the decay of fossils. So over long periods of time, millions and millions of years, we can create more petroleum, but it's still considered a non-renewable resource because we use it significantly faster than we are producing it, then we're making it. So we can't replace what we're using. So we are expected to run out. So when we run out, there's big questions right now in the science field. Like when we run out, how are we going to fuel things, right? Like we're developing electric powered cars and solar powered and all this stuff, but it's just not mass produced yet. And petroleum is so cheap compared to that technology that we're sort of in a bind. Like where are we going to go when that petroleum runs out? Same thing with like so many things come in plastic, and there's been a big movement, a big push to buy things that are in like aluminum packaging or paper packaging. And that's a huge step, but there is still a lot of plastic out there. And so again, using up all of that petroleum. So we did cover this before. I just wanted to have it written down for you guys. So how do we separate the crude oil? Like how do we make it usable? We boil it or we distill it in fractional distillation. So here's another picture of a fractional distillation tower. Has some nice little pictures of, you know, what we use it for. So you can see we use it mostly for fuel. We've got big factories here and big ships, and we've got a train here. These are oil like that you would put into your car or into your boat or something like that. Here's airplanes, here's a car. And then up here we have chemicals and plastics. So we use the smaller molecules for chemicals and plastics, but everything else is some type of fuel. So again, just as a reminder, the small molecules are the ones that make it to the top. You can see in this picture, it says like 1 to 4 carbons is what makes it all the way to the top, then 5 to 9 carbons, and then 5 to 10 carbons, and then 10 to 16 carbons, 14 to 20, 20 to 50, 20 to 70. So you can see that as we go down, we get more carbons. So it's a bigger molecule. So the bottom has the biggest, the top has the smallest. These guys at the top, they take the least amount of energy to become a gas. That's why they're up there, is because it was heated down here and it wasn't able to become a liquid until it got to these very cool temperatures, 20 degrees Celsius. That's colder than room temperature. Room temperature is usually about 22. I mean, I guess that depends on the time of year and stuff, but a comfortable room temperature is about 22 degrees Celsius. Lower density, so smaller molecules tend to have lower density. Bigger molecules have a higher density. And again, the smaller molecules will turn into a liquid from their gas phase. They'll condense back down into a liquid at low temperatures because their boiling points are so low. That's about it. Please let me know if you guys have any questions.